This is Earth, and this is Proxima Centauri b. They are 4.246 light years away from each other, and with current technology, it would take 6,300 years to get there. But let's take a step back. In fact, let's go back to Earth. We are Team Orion. I am Christopher.
I am Taku.
I am Ernest.
And I am Gerard.
For this project, we took inspiration from Project Orion and the Breakthrough Starshot program. Project Orion, developed in the 1950s, aimed to use nuclear pulse propulsion for rapid interplanetary travel by detonating small nuclear explosions behind a spacecraft. Breakthrough Starshot, initiated in 2016, envisioned sending ultra-lightweight spacecraft with light sails to Alpha Centauri using ground-based lasers for propulsion, with the goal of reaching the star systems within a few decades for potential exploration of exoplanets. We're assuming that advancements in nuclear pulse technology means we can reach 21% of the speed of light. This would mean that we'd be able to reach Proxima Centauri within 20 years.
Now, a very important question is whether our mission should be crewed or robotic. We took inspiration from past programs and saw how robots helped pave the way for human exploration. Before Apollo, there was the Surveyor program. Before we sent humans to Mars, we sent the Curiosity, Opportunity, and Perseverance rovers. Similarly, we've learned that robotic missions must always come first to identify issues and act as mission pathfinders. The initial robotic missions will execute calculations, send back data, and give recommendations on actions for humans to act on. However, even with advancements in AI, we predict that the crew will continue to be required to troubleshoot system malfunctions and personally overlook data. Furthermore, the enormous distance between Earth and the ship creates a significant signal delay, hence all decisions and actions must be carried out on the spot without guidance from ground control. Lastly, humans assisted with technology can adjust mission profiles during their flight should any new points of interest pop up. That is why we've chosen an approach to send two ships. This means that communication can be done between ships and humans faster. The crew are protected from dangers since an autonomous ship has gone out ahead of them to scope out the dangers.
Another assumption we made was that cryogenic freezing of embryos and the human body for a long duration of time is unfeasible. If so, they would have to be awake throughout the trip, which poses various physical and mental well-being issues due to the closed environment. To address these concerns, other than carrying out daily research activities such as the study of deep space and its effects on the human health, exercise and communal gatherings, along with food, entertainment such as ebooks, movies, and games, can help them pass the time and provide a sense of purpose. Working on their projects will also provide a sense of purpose and the motivation to keep healthy. We believe, to minimize risk, the astronauts must undergo rigorous training to get them used to the effects of long-term isolation. It is almost inevitable that there will be some kind of mental toll. However, we believe that by properly informing the astronauts of the risk, and with careful screening, the plan is morally sound. In addition to that, they will need a sustainable food source that is not only nutritious but also tasty. This is why we've decided to use hydroponics and aquaponics, the process of growing plants with water while being powered with artificial sunlight. This also cultivates fish, which acts as a source of protein in the diet. In the future, discoveries such as artificial photosynthesis will help tremendously. As aforementioned, fish acts as a source of protein, and plants can act as a source of fiber and carbohydrates. The astronauts can also consume pills to make sure they receive the adequate amount of vitamins to reduce the risk of vitamin deficiencies. By splitting water via electrolysis into hydrogen for fuel, we obtain oxygen as a byproduct. Using modified carbon dioxide fibers, even present in today's day and age, and liquid nitrogen reserves, we can create an Earth-like atmosphere.
Now, on to the mission architecture. Our spacecraft is launched from Earth and assembled in low Earth orbit. Then, we conduct a trans-Jupiter injection to put us on course with Jupiter and Europa. Europa is known for having huge resources of ice and liquid water, acting as a pit stop for our spacecraft. This infrastructure is extremely crucial as it builds the foundation that allows multiple continuous missions to be sent to Proxima Centauri. Robots will dig through the ice and collect water, which will then be split into breathable oxygen and hydrogen, which will be used to manufacture the bombs. Other potential pit stops could be the Kuiper Belt, where we collect small icy asteroids for refinement to produce fuel. Reusable shuttles would send these to the main ship to refuel, and next, we use the gravitational pull of Jupiter to conduct course corrections and sling us towards Proxima Centauri. During the coast phase, we unroll our large but very thin solar sail, powered by a laser positioned in low Earth orbit. This provides a constant acceleration of about 0.92 Gs. The artificial gravity created will solve a multitude of muscle and skeletal problems faced in zero-G environments. And after 20 years, the autonomous rocket would reach Proxima Centauri and assess its habitability. If proved habitable, we would send our rocket to land so that the astronauts can take samples and develop the area. A habitable area is characterized by factors such as temperature, presence of water, and resources for 3D printing. If not, another gravity assist will be used at Proxima Centauri to sling the spacecraft back to Earth. Now, with a crew of 40 astronauts and all the developments stated above, we believe that such a trip may very soon be further from sci-fi and closer to reality. We must search for the answers and uncover the truths. Is life common? Are we alone? What makes mankind special? That, everyone, is what we're all about. This is not just some vague ideas, but a stepping stone for advancing human intelligence and our understanding as we know it. This is what Team Orion is all about, and we are extremely excited about what lies ahead. Are you?